This time we are going to convert the decimal numbers to binary, and we are going to use at this moment repeated division by 2 method. How it works? Simply take the decimal number and divide by 2. 4 divided by 2 is equal to 2.0. Next, you're supposed to take the decimal part of the answer and multiply by 2. So I have 0 times 2 gives me 0. Next, you're supposed to take the whole part and divide by 2 again. 2 divided by 2 is equal 1.0. Again, take the fractional part of this number and multiply by 2. 0 times 2 is equal 0. Next, copy the whole part, 1 over 2 again. Anytime the numerator is less than the denominator, you simply copy that numerator to the side. This is your least significant bit, and this is going to be your most significant bit. Means that decimal 4 is equal to binary 1, 0, 0. Okay, remember this is your most significant bit, and this is your least significant bit. This method is very good method for small numbers, small decimal numbers. But if you are going to deal with large numbers, this division is going to go forever. So what technique do I use in order to make the process shorter? I simply write the weights of the binary numbers on the side. 1, 2, 4, 8, 16, 32, 64, 128, and so on, so on, so on. And simply do something like this. I have to convert 4 to binary. What am I supposed to do? I'm supposed to write 4 and ask myself question, what is the highest number from this sequence which I can subtract from 4? My answer is 4, right? 4. Now, 4 minus 4 is equal 0. So, I subtract 4, and whatever I didn't subtract, to the right side, I'm supposed to fill up by zeros. And this is my binary 4. Let's take a look how we are going to convert 8 to the binary using this subtraction technique. I have 8. My question is, what is the highest number from this sequence which I can subtract from 8? The answer is 8. And because I subtract 8, I have to mark 8 by high. And 8 minus 8 is equal to 0. If you are going to end up with 0, means the problem is solved. Everything else to the right side supposed to be filled up by zeros. So my binary 8 is 1, 0, 0, 0. This is base 2, and this is the solution to my problem. Let's take a look at this example. I have 10. Again, you can always write the weights on the side, 1, 2, 4, 8, 16, and ask yourself, what is the highest number from this sequence which you can subtract from 10? The answer is 8. So subtract 8. 10 minus 8 is equal 2. The question is, what is the highest number from this sequence which I can subtract from 2? The answer is 2. Because you subtract 2, you have to mark 2. 2 minus 2 is 0. Everything else you're supposed to fill up by zeros. The empty spaces fill up by zeros. And you are going to end up with 1, 0, 1, 0. So this is binary 10. And this is the solution to my problem.